let's calculate the pH of a buffer solution after the addition of a strong base. So we know this is a buffer because this is an acid right here, and that's acetic acid, and the C2H3O2 is a weak acid slash base, so therefore that is also the same thing, and that's why it's a buffer, because the Na means base and the H always is an acid, but this is a weak acid and a weak base. And when you typically see these, I like to think of them as opposite sides. One of them is always going to be on the left side, and one of them is always going to be on the right side. And since the question is saying after 35 ml of NaOH, we know that therefore this base right here, the NaC2H3O2, will be on the right side, because after adding NaOH here, I'll draw it right here. So HC2H3O2 plus, see if you do plus NaOH, which of course is going to be like a single arrow because NaOH is a strong base, and that creates H2O plus NaC2H3O2, which you see right here. So in these type of problems, you always, when there's different amounts of like volume in liters, you always want to put all of the things into moles, all the stuff that we have into moles. So we know that what is a pH of the buffer containing 1 of H2H3O2, and okay. So we know that the starting for H2H3O2 is going to be 1 M. And we're going to multiply that by the volume, which is added to the 2 liter of the buffer solution. So we know it's 2 liters. So we multiply this by 2 because, of course, M molarity is equal to N over V. M times V is equal to N. And that's what we're doing right here, M and V. And remember, V has to be in liters. So we have 2. Okay, so we know that this is 2 mole. And the NaOH, let's do the NaOH, it's going to be 0, well, actually not NaOH, NaC2, H3O2, acetic sodium acetate. Okay, 0.50 times, again, since it's a part of the buffer solution, because it's on the left side, times 2, which just equals 1 mole. So 1, no, wrong thing, 1 mole. We also do have information about the NaOH. So we could do, of course, the NaOH is 0.80 M molarity times the volume, which is 35 milliliters. So when we divide that by 1,000 to convert, so 35 divided by 1,000 gives us liters, and that will be 0.035. And when we do that, let's see what we get. Zero 0.028 moles. So when you get to this step, we have our stuff. So we could just write our ice table, I guess, if you want, whatever is easier for you. But we can know that this is a limiting reactant. Right here, this is a limiting reactant because, of course, we're going to have to finish all this before we could finish this. So remember this from General Chemistry 1, where now you subtract the lowest amount of moles in the solution. So this is at 2, this is at 0.28, and this is at 1. So 0.028 is the least amount. And of course, I'm only talking about the reactant side. It's only works for the reactant side. So if 2 is the lowest, then we would subtract 2. But forget about the product side as of right now. So the equilibrium would be 0. And when we subtract 0.028 from 2, let's see, 2 minus 0.028, 1.972. And again, I like to draw lines here. And since this is a liquid, we can just cross that out. Because remember, liquids in a K equation, the liquid is always just 1, or a solid. They're always just considered as the number 1. Okay, so since we're removing from the left side, we therefore must add on the right side. So 0.28. So 1 plus 0.28 is 1.28. 1.028. So with this, they want to know what the pH is. So now we can, of course, use our equation. Now, of course, this equation is pH is equal to pKa plus log of our conjugate acid and our acid. Okay. And of course, before we plug it in, we know that they're in different volumes. So when they're in different volumes, we add the amount together. So we have 35 ml, which we figured out is 0.035 liters, plus 2 liters, which equals 2.035 liters. So we grab our moles, and of course, since this is in concentration, how do we get the molarity, which is N over V? So M is equal to, let's start off with this one right here. M is equal to 1.972 divided by 2.035, which is equal to I got 0.969. Okay, and since this is our acid, we can plug that in for our HA. So then let's do the same thing for the other one, which was 1.028 divided by 2.035. Of course, molarity 1.028. 0.505, say 2. And of course, this goes as our conjugate acid. Conjugate base. And now when you solve this, of course, our pKa, my fault, is negative log of our Ka value right here. Plus all of that. Okay, so negative. And our pH is equal to 4.46 equals pH. Thank you.